Hello everyone and welcome to the 12th tutorial in our series. In the previous tutorial, we unlocked the power of methods and we found new ways to make use of objects in our games. Today we'll be looking into another important feature of instances known as events, and we'll see how we can use them to create some fun interactions. So what is an event? An event is like pressing a button and making something happen. Think of it like this. When you press a light switch, that action is an event. The light knows to turn on when you press the switch. In Roblox, objects in your game can also know when certain events happen, like when a player walks into a room or when they click a special item. As a scripter, we can listen out for these events and connect some functions to them when they occur, doing anything we want. For example, picture a lava area in your game. We want it to hurt a player who walks over it. How do we do that? Let's find out. Firstly, create a part in Studio and drag it off the spawn location. Make sure you have one of these building tools selected so you can drag it. Now let's make our part look like lava. So we'll change the material to something like neon, so it gives it a nice glow. We'll also change the color to make it more like orangey red. So something like this maybe. I think that looks okay. Next we'll change the size, so if you press the scale button, you can also press 3 or Control 3 to toggle the scale tool, and you can size out your part so it's a lot bigger. Maybe you can also make it shorter as well, like that. And finally, we'll change the name to lava. And now we have our lava part ready. Time to make it deal some damage. Let's create a script in service and grab that lava part we just created and store it in a variable. So we'll do local lava equals workspace.lava. Now, parts have a built-in event called touched, which fires whenever the part comes in contact with another object through physics, like when a player walks over it or when a ball rolls down it. So we need to find this event inside the lava pot and connect a function to it. So we index lava with a dot and the event name, which is simply touched. And you can differentiate between events and normal properties with this symbol here. So events have this purple lightning symbol, but if we look at lava.transparency, which is a property, we have a blue cube, a blue square. So if you see a purple lightning symbol like this next to the name, that means you are dealing with an event. So now that we have the event, we can store this in a variable. So we can do local event equals lava.touched, and let's try printing it to see what it says. Let's press play. And it says signal touched. Signal is just another word for event, so event touched. Perfect. Now we can connect a function to this event, and we do that using the touched events connect method. So event colon, because we index methods with colons, so event colon connect. And don't forget the parentheses, because remember, methods are just functions. So event colon connect. And in these parentheses, we pass a function. So let's create that function first. So local function, I'll just call it deal damage. And don't forget the parentheses and end. And in the function, we can just add a print statement to see if it works. Saying, ouch, something touched lava. And finally, we pass the name of the function we just created inside the parentheses of the connect method. So we'll just write here, deal damage. And now with the function, the connection to the event is complete. We have the event, which is touched, and we connected a function to it. Now let's test the code. It's already saying something touched lava. So if I walk over the part now, it says, ouch, something touched lava. Perfect. So this deal damage function is called whenever the touched event of the lava is triggered. But how do we know what triggered the touched event? Whenever the event calls the deal damage function connected to it, it also passes an argument to the function. And that argument is the object that triggered the event. We can catch that argument by assigning a variable to it in the parentheses of the function. So you can call it something like trigger or even object. I'll just call it object. And now we can update our print statement to also show the object. So you can do ouch and then make that into a separate string, comma, object, comma, touched lava. So print ouch, object touched lava. And now if you test the code, it tells us what is touching the lava. So right now it says base plate touched the lava. If you walk over it, it says a bunch of things are touching the lava here. So now we know what is triggering the touched event. If you enable the select tool and click on your avatar, it highlights a model in the workspace with your Roblox username. This model is known as your character, and it's what you control when you play games in Roblox. If you expand the character model to see its children, you'll see many different objects inside. So we have some accessories, some scripts, and even lots of mesh parts or parts. If the parts in your character look different from mine, don't worry, you probably just have an R6 character. I'm using an R15 character, so I have 15 different mesh parts that make up my character's body. If you have an R6 character, you'll just have 6 parts that make up your character's body. So I have a right foot, a right lower leg, and right upper leg. But if you have an R6 character, you'll just have one right leg. And it's these parts inside the body that trigger the lava's touched event, which is why we see them mentioned in the output. So you can see that the left foot is triggering the event. The left lower leg sometimes triggers the event, and even the right foot triggers the event as well. So it's these parts inside the model that trigger the event. The model itself can't trigger the event because there's nothing really 3D about a model. It's just like a folder for these objects. Looking back at our code, we've managed to detect whenever an object touches our lava part, and we managed to find out what that object touching it is. Now we're ready to finish off our deal damage function and make sure it actually deals damage to us. But how do we do that? If you look back inside your character, you should see an object called humanoid. This is a special object that is only found in models. It gives a model the features of a controllable character, so it lets it walk around, jump, play animations, etc. And humanoids have a property called health. It's this property that controls a regular character's health in a game. It usually starts from 100, and once it reaches 0, the humanoid dies. So it's this property that we want to edit in our deal damage function. To get to it, we'll have to find the character's humanoid when one of its body parts trigger the lava's touched event. But let's see, what can trigger the lava's touched event? The first object says base plate. The base plate can trigger the touched event because the base plate and the lava part are touching each other. But we don't want to deal damage to anyone when the base plate is triggering the event. We only want to deal damage whenever a character walks over the lava part. So we need to differentiate between when an ordinary part, like the base plate, triggers the event, and when a body part, like the left foot, triggers the touched event. So can you think of any way we can do that? One way could be to make a list of all the body part names. So we'd make a table and write down head, left foot, left hand, left lower arm, etc. And then we check if the object triggering the event has the same name as one of those in the list. If it does, we'll treat it as a body part and try to deal damage to the character it belongs to. However, this is pretty tedious and can be easily broken by just naming any ordinary part to the same name as a body part name. For example, we could change the base plate's name to left foot for some weird reason. And when we compare the names, and when we compare its name to one of those in the list, it will be counted as a body part, because it now shares the same name as one of those in the list, left foot. So comparing names to determine whether we're dealing with a character or not is not a good idea. Another way could be to check if the part triggering the touched event has a model for a parent, because all body parts are children of a model. The problem with this solution is that you can have a model that isn't a character, like a car. So just checking if the parent is a model isn't enough. A better and more precise way would be to check if the triggering object's parent has a humanoid inside. Remember how earlier we learnt that humanoids are only found in characters? We can use that differentiation between normal models and character models to check if the triggering part is a body part. So all we need to do is check if the triggering object, its parent, has a humanoid inside. If it does, then we'll know we're dealing with a character walking over the lava. And to write that condition in our code, we'll firstly try to store the humanoid in a variable. So local humanoid equals object.parent humanoid, and then we'll add an if statement to check if the humanoid variable is actually storing something and it's not just empty. So if humanoid is not equals to nil, then print deal damage. Now let's test the code, and we got an error. It says humanoid is not a valid member of workspace on line 9. So if you go back to the script, on line 9, it says we have an error here. Humanoid is not a valid member of workspace. Why did we get this error? Let's see. So our print statement above the error says, ouch, base plate touched lava. And if we show the sources in the output again, this happened on line 7 in our script. So if you go to line 7, we have a print statement here which says, ouch, object touched lava. And in this case, the object variable was storing the base plate, which is why it says that here. So, ouch, base plate touched lava. Now, skipping line 8, let's go to line 9. What did we try to do here? We did local humanoid, so we created a variable called humanoid. And what did we assign it to? We made it equal object, which is the base plate, dot parent, which will be, so base plate dot parent, which is the workspace, dot humanoid. So we did workspace dot humanoid. Is there an object called humanoid in the workspace? No. So we tried to index the workspace with a non-existent child called humanoid. And that is why we got the error, humanoid is not a valid member of workspace. So how do we avoid this issue? How do we not index an object with a non-existent child? Do you remember from the last lesson when we learned a particular method which lets us find a child of an object with a specific name, and if that child exists, it returns that child, otherwise it will just return nil and not an error. That method was called findFirstChild, so we can use that method to verify if the object's parent has a humanoid or not. But let's use a different variation of that findFirstChild method, and let's use object.parent findFirstChild of class, and inside we'll just write humanoid. So this method tries to find a child inside an object with the same class name as the one you give to it. We sent the class name humanoid because we want to find a humanoid object inside the triggering part's parent, no matter what it's been named as. So that's why we're using the findFirstChild of class method instead of the simple findFirstChild method. Now let's test our code. And if you noticed, when the base plate triggers the event, it doesn't say deal damage in the output, so this condition wasn't true because it couldn't find a humanoid. But if you walk over the lava with our character, it now says deal damage whenever one of our body parts trigger the event. And now we're ready to actually deal damage to the humanoid. All we need to do is reduce the humanoid's health property. So let's change this to humanoid.health equals humanoid.health minus 10. So humanoid.health equals itself minus 10. Now let's test the code. And as we walk over the lava, it deals damage. But that was pretty fast. There wasn't any cooldown. So anytime one of our body parts touch the lava, it's immediately going to reduce our health. We'll need to add our own cooldown to the function. A simple way to add a cooldown is to use a debounce. A debounce is just a variable that kind of acts like a switch, allowing or not allowing some code to run using an if statement. So at the top of our function, we can create a variable called local is on cooldown, and we can set that to false. Now in our if statement, where we're checking if the humanoid exists, we can add a second condition here using the AND operator and check if the is on cooldown variable is still false. If the is on cooldown variable is still false, then we can deal damage. Otherwise, we can't deal damage. So if humanoid is not nil, and if the is on cooldown variable is still false, then we'll set the is on cooldown variable to true before dealing damage to the humanoid. And this will stop the if statement from ever being true again, which means we've prevented the event from just spamming our character to death. Let's test the code. And when we walk over the lava part, now it only deals damage once. And as you notice, the event still fires, but our health no longer decreases because the if statement no longer checks out. But you do need to reset the variable back to false so the function can deal damage again. We can do that after a 1 second delay. So we'll add a wait statement of 1 second and then set the isOnCooldown variable back to false. And now if we test the code, it only deals damage to the character once per second, like so. And this is how we can add cooldowns to functions. Now, what if we want to disconnect a function completely when we no longer need an event? When you use the connect method of an event, it returns something called a connection, and we can catch that connection by assigning a variable to the statement. So we can do local connection equals event colon connect deal damage. And we can print the type of this connection to see what it says. Let's test the code. And if you enable the sources in the output again, it says on line 21, RBX script connection, which just means Roblox script connection. So now that we have the connection stored in a variable, we can break or disconnect it very easily and stop our function from listening to the event. All you have to do is use the connections disconnect method. So connection colon disconnect. This line tells Roblox to stop the link between the function and the event. It's like saying we're finished with the event now. But let's add maybe a 10-second wait before disconnecting because we don't want it to happen immediately. And after that we can add a print statement saying connection dropped. Now let's test the code. So far the connection is still running, and if you walk over it, it'll deal damage. And after a few seconds it will say connection dropped, and if you keep on walking over the lava it does nothing. So the link between the function and the event was dropped, which means the touched event no longer calls the deal damage function. So this can be very useful for listening to events temporarily. Another thing to take note of is that if you do disconnect a connection, you can no longer fix that connection. So you can't do something like connection colon reconnect. This wouldn't work, and there's no method called reconnect in a connection. If you do want to listen to the event again after disconnecting, you'll need to create a whole new connection again. So instead of connection reconnect, we can do local new connection equals event colon connect, and then we can put in deal damage. So the same function as before. And here we can just write print connection fixed. So here we have created a new connection. We have listened to the event once more. And if you just add a wait statement before it, we can add a wait of 3 seconds, and then we can press play. So if you walk over the lava, it deals damage to us, and then after a few seconds the connection drops, and after a few more seconds the connection will be reconnected and it starts to deal damage again. So this is how we listen to an event again after disconnecting. Now imagine a situation where you're not interested in linking a function to an event. You just want to wait for a particular event to occur before continuing with your code. For example, waiting for a player to click a button before starting the game. You can do that very easily using an event's built-in wait method. In this example, I have a part with a click detector inside. Click detectors are just simple objects you can put in parts to make them clickable. In the code, I am waiting for the mouse click event to occur using its built-in wait method. This line tells Roblox to pause the script and keep waiting until the mouse click event occurs. And once that event happens, Roblox resumes the script from where it left off. So right now it says waiting to be clicked, and if you click on the part, it says starting game. And remember how some events provide values to functions linked to it? Like how the touched event gives the triggering part to the connected function. You can get those values when using the wait method by assigning a variable to it. The mouse click event returns the player who clicked on the part, so we can catch that player in a variable. And then add a print statement saying player clicked the button. Let's test the new code. So it says waiting to be clicked, and when we click on the part, it now says I'm hiatus, click the button, and starting game. So this is how we can wait for events to fire. And we can achieve something similar with an events once method. In this code, I am getting the same part with its click detector inside, and I'm still searching for the mouse click event of the click detector. On line 5, I've created a function called startGame, which expects a player parameter. So when this function is called, it expects a player to be passed to this function as an argument. Now what does this function do? It prints player, click the button. So whatever is stored in the player variable, click the button. And then it also prints game start. On line 10, I've created a variable called connection. What does this connection variable equal? It equals event:once. Event:once. So I'm using the once method of the event. And I passed the function I created here, start game. So what does this line mean? It means that I have connected this function, start game, to the event, but it will only listen to the event once. So when the event is triggered, it will call the function, and then it will disconnect it automatically. And that's why on line 12, I have a while loop. And the condition is while connection.connected, so the connected property of the connection is still true, which just means while the connection is still connected, do print waiting to be clicked and a wait of 0.2 seconds. I just have this wait here so that we don't crash or freeze the game. Let's test the code. So right now it keeps printing waiting to be clicked because of my while loop. And when I walk over to the button and click on it, it stops the while loop. And it says, I am hiatus, click the button, game start. So the function was called when the event was triggered. And the connected property of the connection became false because this once method automatically disconnected the connection. Some final notes before you finish up. When using the connect method of an event to link a function, you can actually create the function directly in the parentheses like this, instead of creating it separately in a variable. This type of function is known as an anonymous function because it doesn't get a name. In this example, we've connected an anonymous function to the Lava's touched event. The function is created right where we connect it, and so it doesn't get stored in any variable. Many scripters use anonymous functions when the function is kind of short and doesn't need to be reused anywhere else in the script. It helps keep the code more concise and less cluttered with unnecessary variables. Keep experimenting and soon you'll find what works best for you in different situations. Also, let's enhance our function. We can simplify these conditions here. We used if humanoid is not equal to nil to check if the humanoid exists. We can make this shorter by simply saying if humanoid. This new condition checks if the value stored in the humanoid variable is neither false nor nil, which is just doing a little more than what we had before. But we can use this condition to check if the humanoid exists. And instead of the is on cooldown equals false, we can change it to and not is on cooldown. Remember the not operator? It checks if the value after it is either false or nil. The is on cooldown variable is only ever set to false or true, so we can use this condition to make our code more concise. And now we have much smaller conditions which basically do the same thing in this case. Currently we're modifying the humanoid's health property directly by assigning it to a new value. Another way to reduce the health of a humanoid is to use its TakeDamage method. So humanoid:TakeDamage. If you pass a positive number, it will decrease the humanoid's health by that amount. But if you pass a negative number, it will try to heal the humanoid's health by that amount. The TakeDamage method also takes force fields into consideration. So if there is a force field around a character, like when a character spawns on a spawn location, the TakeDamage method won't affect the humanoid until it wears off. By simplifying conditions and exploring different ways to achieve the same result, you're improving your scripting skills. So be sure to keep experimenting. And that's all for this lesson. We've covered many different things so far, so I would highly suggest practicing with the concepts after each video if you're not doing that already. And if you do have any questions, please feel free to ask them in the comment section and I'll try to respond as soon as I can. As for an assignment, try to create a never-ending staircase where the next step only appears when you walk on the previous step. You can even give the steps random colors using the math.random or the brickcolor.random functions. Thank you for watching. I hope you all have a wonderful day and I'll see you in the next one.